This is question 18 of Antiderivatives 2. A defense contractor is starting production of a new missile control system. On the basis of data collected during the assembly of the first 4 control systems, the production manager obtained the function L prime of x equals 4200 times x to the negative 1/2, describing the rate of labor use. For example, after assembly of 4 units, the rate of assembly is 2100 man-hours per unit, and after assembly of 25 units, the rate of assembly is 840 labor hours per unit. The more units are assembled, the more efficient the process. If 16,800 labor hours are required to assemble the first 4 units, how many labor hours L of x will be required to assemble the first x units, and then the first 25? So before we answer this first one, I'm going to write out dL dx equals 4200 times x to the negative 1/2. We're going to multiply both sides by dx, then antiderive both sides. So now we'll go answer that question. Take the indefinite integral, that's the same thing as antiderive. So we're going to take the indefinite integral of L prime of x. Well done. Now we'll go back and go ahead and do that. So L of x equals 4200. And if I add 1 to this exponent, I'm going to get x to the positive 1/2 divided by positive 1/2. 4200 over 1 times 2 over 1 times x to the 1/2 plus c. Should have been a plus c there. So L at x equals 8400, and then x to the 1/2 is the square root of x plus c. And our initial condition is L at 4 is 8400 times the square root of 4 plus c, and that has to equal 16,800. And then the square root of 4 is 2, and twice 8400 is 16,800. So 16,800 from both sides, so c equals 0. So my function is just going to be the 8400 times the square root of x. Well done. And then the number of hours that will be required to assemble the first 25 units is, so that's going to be 25 in for x, so it's 5 times 8400. We'll just do that in the calculator. 5 times 8400, so 42,000. And that concludes this video.